Hello again. Welcome back. Today we are broadcasting from a little place called Box Canyon in Colorado. This is a piece of the canyon. This is really cool because this is actually 1 billion years missing in time here. See how these rocks go straight up and down and the other ones are over top? 1 billion years of Earth history. It's right there in that layer. Missing. Anyway, it's an unconformity. So cool rocks, stuff, some fun background. Today we're going to talk about taxonomy and how to create what's known as a dichotomous tree/key. And we're also going to identify trees based on their leaves. So I'm giggling because my dog came downstairs. She was sound asleep and she's looking at me like, who's here? Who are you talking to? Nobody. Future students. Okay, so let's take a look at taxonomy. So I opened up the taxonomy folder in your lab section. I will try to get better at sharing my screen. Okay. So you can just read through this. There's a couple of videos that explain using a dichotomous key, just kind of a generalization of how it's used. So watch that video. And then you're going to use these leaf images to identify your leaves. Now, I'd like you to do this part first because it walks you through and kind of familiarizes you with the steps of using a dichotomous key, because you're going to be creating one with some examples of bugs from the lab book. So we do this part first and then we kind of like reverse engineer the exercise. So let's just look at what I'm talking about. So these are the leaves that you're going to identify. It's a Google Drive. You shouldn't have any trouble accessing it. And so you can see there's just a bunch of different leaf varieties. Here, double click to see the whole thing. Sometimes the leaf is down at the bottom of the baggie, and so you can't actually see it unless you click on the image. And then for some of these, you may need to really zoom in because some of the questions are going to be about the leaf margin, and the margin is just the edge of the leaf, okay? So the other thing we look at is here, the leaf key. Now, you probably don't know what it means to be opposite or alternate, simple, lobed, compound, all this like vernacular, right? These words that you see here. So you got to read through your lab. Like with every other lab, you got to read through your lab. So let's go look at the lab so we can get an idea of, what those words mean. Now, you should be using your table of contents. So let's check out, okay, where is taxonomy? We are on page 83. Is where it starts. So you have access to this document. I mean, you should know that at this point. The lab manual is free. So scrolling down taxonomy, you're going to read through this, talking about, a little background of taxonomy, and then some background on taxonomist keys. Sorry, I should probably turn my phone off when I'm doing videos. And I'm gonna cruise ahead, okay, to the leaf part. So here's if you were doing this in person where you would be writing your leaves. Now, leaf names. Now you can use your lab manual as like a scratch pad. You can kind of fill out your 13 leaves here, make sure that you're sure that they are the one that you think they are before you go and you enter them into the activity. I just think it's a good thing to do, just so that way when you get into the activity, you're not like, oh, which one was that? Gotta redo it again. Anyway, here is some leaf terminology, okay? Don't be confused by the difference between needle and leaf, okay? If it's not needle-like, then it's a leaf. It's kind of weird to think about it that way, but that's the way the key works. It will say it's not at all needle-like or it is needle-like. If it's needle-like, looks like a pine needle of some sort. If it's not pine needle-y, well, then it's any variety of leaf, okay? A smooth margin is where the edge is literally smooth. A toothed margin is where it's toothed. Now, lobed can be tricky. Notice how in this leaf, these two leaves right here, these are both considered simple. I know it doesn't say it here, but they are. And then they are unlobed. And there's one singular main vein that runs from the stem to the very tip of the leaf. Now, if we zoom in on the maple leaf, you can see that these lobes, which are kind of like hunks, okay, chunks of the leaf, they have a vein that starts in the middle and goes all the way to the tip of each and every lobe. So there's not just one vein, right? There's multiple veins that all go from the center to the end. Now, that is not perfect because nature is not perfect. So you will not always, every single time, see the veins going from stem to tip on a lobed leaf, but it's a good rule of thumb, okay? So if you have multiple veins going from the stem to the tip in multiple parts of the leaf, as opposed to just one main vein, it's a good likelihood that you've got a lobed leaf. I mean, really all lobed means is you have like lobes, like literal lobes, okay? Hunks and chunks of a leaf, not just like one main whole leaf. These two are one main whole leaf. This one is like, yes, it's one leaf, but it has kind of pieces to it. That is lobed. Okay. Simple is a single leaf. So when we're looking at the branch, okay, and here we can see a little piece of the branch, the stem goes to a singular leaf, okay? Whereas with compound, and let me just zoom back out a little tiny bit here, okay? With compound, the stem, so you don't see the branch here, but this would be branching off, or I guess you'd say stemming off of a branch, and then there's multiple leaflets. Now there's a couple different types of compound. We have singular compound, where you have branching of just one main stem, okay? And then we have, they branch, but then the leaflets branch a second time. So you have the main stem, and then you have these kind of like secondary stems that also have branching happening. So it branches and then it branches again, all right? That's pretty simple to tell the difference. You only have one tree leaf that is double compound, just one. So should be easy to notice. Then opposite versus alternate, because we don't have the whole tree and we don't have like say a small length of branch to look at, we don't know how the leaf is coming off of that branch. If it's opposite, it comes from the same node on the twig. And if it's alternate, there's one, and then a little bit further up, there's the other, it goes the other direction, a little bit further up, it goes the opposite direction. And so it alternates one by one in direction, as you can see here in these images. Because we don't have the branch, the leaf tells you. So let's go back to those leaf pictures. Up on the top, there we go, of the leaf, it says alternate. So you don't have to figure that part out. That part is already done for you on every single one of these, okay? A lot of them are alternate. Let's see, leaf 2, let's open leaf 2. Is leaf 2 opposite? I forget, no, it's alternate. But you'll come across an opposite, okay? But it's written up there next to the leaf number. So once you've identified your leaf, you write that down in your box. Keep leaf 1 is whatever it works out to be. And then you enter that into the activity. Now, let's use the key. Okay, so I'm going to call up leaf 1 again, and we are going to zoom in again because we got to look at that leaf margin. Okay, now think about it. Would you say that this leaf, we already know it's alternate, so we're going to start there. Would you say it's simple or compound? One leaf, it's simple. Okay, is it lobed or unlobed? Is there one main vein going up from the stem to the tip, or are there multiple veins with hunks? There's one main vein. Good. Okay. So then look at that margin. Is it, so this is an unlobed, not a lobed leaf. It's simple, it's unlobed. And what about that margin? Is it smooth or toothed? Well, obviously it's got teeth, okay? And if we zoom in a little bit more, you can see that on each tooth, there's like littler teeth. So it's kind of like a saw blade, right? So on this whole tooth, you could say it's double tooth, or even in some cases, triple toothed. This one's a triple, this one's a triple, that one right there is a double. Okay, so it's not perfect, it's nature. Nature's never perfect. But it's not singularly teeth. This would be double teeth. So let's keep all that in mind. We'll go to our leaf key. So let me move myself out of your way. So we're going to use this. We're going to say, okay, think about that leaf image, and you can call it up and look at it as you're using this, download stuff, open multiple windows, whatever you need to do. So first we're looking at 1A or 1B. Now I want you to pay attention. If I've lost you, come back, because this is going to matter when you get to making your own key. Notice how every single number has an A or a B. That's because we're looking at whether or not the feature is there. So when you are writing up your key, because this is a key, you're going to do your own key, you need to consider your characteristic as being or not being present. So does the critter have legs or doesn't it have legs, kind of thing. And that will make sense when we get there. We're going there momentarily, okay? So each number gets an A or a B. And then notice over here, this is our go-to. So if I were needle-like, I would then go to number 2. And I would jump down here and I would say, okay, let me consider the characteristics of 2 and decide what I do from there. If I were a needle and they were small, scale-like, and close together, overlapping, I would be a red cedar. But if they were any of those things, I would be a Scotch pine, okay? That is if I was needle-like. Now our leaf is not needle-like, so we're not in that group. I'm just showing you the example kind of where you go next, okay? Because it's gonna be relative, you're gonna be able to relate to this when you're building your key. Okay, so let's do our leaf. Let's look at it one more time. There's our leaf. It's alternate, it's simple. It's not lobed, and it has teeth. Here we go. So leaves, needle-like or scale-like? Not us, okay. Leaves, not at all needle-like or scale-like. That's us. Where do we go? We go to 3. We go to 3, okay. My leaves are opposite. What did it say? Did it say opposite or alternate? It said alternate, okay, so we're not opposite, we are alternate. So I go to 5. Now notice that it's not 5A or 5B. I don't know if what my next characteristic is until I get there. So when you're writing up your key, A's and B's don't belong over in this column. You don't know that until you get to the number, compare the characteristic of A and B to decide which one you are. You can't tell your reader, oh, you're A. You don't know that yet, okay? So our leaves are alternate, we go to 5. Okay, we said, let's look, 5A, 5B. Leaves are simple versus leaves are compound. Well, we had one leaf, it didn't branch. We are simple. We go to 6, all right, 6. It's like a puzzle, it's kind of fun, okay. 6A, leaves are lobed. 6B, leaves are unlobed. You remember, was ours lobed or unlobed? Unlobed, okay. So we go to 8. We go down to 8. Our leaf margin is smooth. Not us. Our leaf margin is toothed. Cool. I go to 10. 10. Leaf margin with sharp double teeth, leaf shape elliptical, leaf distinctly lopsided at base. That's a lot. That is a mouthful. I'm not sure. Let me take a second look. Let me check out B first. Leaf margin single teeth. Well, right there I already know. I am not B, which means I must be A, because I have double teeth, not single teeth. But let's just check out the other character. Elliptical, what the heck does that mean? Is it lopsided? Lopsided means it's not equal on both sides. Well, let's just make sure. So does that look like a circle or an oval? Like if you needed to put that shape over this thing, would it fit perfectly inside a symmetrical circle, or is it a little more like stretched out like a football shape? Football shape. It's elliptical. Okay, cool. So lopsided. Well, let's see. Look at the two different sides. Like one side's kind of thin, another side's kind of a little more spread out. So, you know, I would have to like shave off this portion of the leaf to make it perfect and symmetrical. It's not. It's a little lopsided. It's got a little extra going on over here. Okay. So all of those characteristics match our leaf. We are, where are we? We are American elm. So that's what you would write for number 1. Okay, now I picked one of the hardest leaves to do so that I could walk you through kind of all the variety that you might encounter. So you got number 1 done, all right? Now go ahead and do the rest. Okay, moving on. Now we're getting to kind of the hard part. And if I've lost you, please come back. If you're making coffee, come back to your computer and listen intently. So the next part that you're going to do is activity 2 and activity 2, because again, there's part 1 and there's part 2. Don't let it confuse you. You are going to construct a branching tree diagram from which you will create a dichotomous key. And you are going to do this on the critters in your lab manual. So we're going to scroll down. What the heck are you talking about, critters? Scroll up, actually. Here are your critters. Critters A through J. Now, some of the mistakes that I've gotten in this lab is students will just do any creature. And as an instructor, when you have more than one student make the same mistake, you have to ask yourself, why? So I asked those students who did this previously, what made you think that you needed to do, you know, I had one kid do wolves and dogs. And he said, I don't know, I just thought that's what I was supposed to do. And to this day, I still don't understand, but I had 3 people do it in one semester. And I was like, where is it coming from? It doesn't say it in the directions. It says do critters A through J. This is activity 2. Okay. I have no idea why my students have done. Don't do that. I can't give you credit for it. And then you have to like go back and do the whole lab again. Do these critters, okay? These are the critters right here, critters A through J. This is what you need to base your branching tree diagram and your key on. Characteristics of these made up bugs, okay? It even says it in the lab manual here, or excuse me, on the activities. It says right here, all critters A through J, and this is associated with activity 2. So I don't know where the communication breakdown is to this day, so we're just gonna call it a fluke, move on. Hopefully everybody watches the video and you don't make this error. Okay, so moving on. How do we do this? Well, let's go look back at the lab manual because it's gonna walk you through an example. I mean, it seems like a big old puzzle. I mean, it is, but it's pretty straightforward, okay? So we start off using an example. So activity 1 is just a walkthrough of an example. We have shapes, okay, A through E, and the job is to get them broken down by their characteristics so that each and every one of them is identified. That means that when you're going and you're making all of these boxes and you're separating characteristics into each box, when you have the shape identified, you're going to have only one letter in your box and then you're done. You can't break it apart anymore. When you look at these letters, and the same is true for, you know, the quote critters, consider them to be species, okay? They could be species of anything. They could be species of fly, species of worm, species of cat, okay? It could be, and envision them in that way. A represents a particular species. B represents another species. Okay, they're all different species, and we are trying to differentiate them based on their characteristics. Now, we're not using real critters because, well, quite frankly, that's difficult to do in nature, and it's what an entomologist does. So we use shapes and we use critters so that we understand the concept of dichotomy. Okay, so moving on. The first thing that you do is you start off with what's known as your superset. All shapes, critters, A through E, one box, they're all together. We haven't broken them down. Now, di means those, right? Two, okay? And so every time you break down a single box, it has to be into two new boxes, okay? So we do that and we break them down. We're gonna be squares and not squares. And we're gonna use not squares because circle and triangle, not squares, right? So they fit. So we do squares and not squares. Well, A and B are only squares. C, D, and E are not squares. So you make a box and you put your critters in the box. You put their name and their characteristic, okay? When you do this at home, make sure you follow those rules because I have to take off points if you don't. It is in the directions, okay? You're gonna break down your boxes, you're gonna draw your lines, try to keep it neat, okay? If you're doing it by hand and it's all messy with scratch outs and stuff, just do a final draft so that I can read it clearly. And then in each box, you put the characteristic as well as the critters that belong to that characteristic. That is going to help you keep it organized, okay? And not lose points. So now we're gonna look at squares and we're gonna break squares down. Now this portions them out. On yours, you're gonna have your lines coming straight off the square box. So I'm just gonna go down to the final, okay, which is here. This is the whole final product tree diagram, branching tree diagram. We start off with all, we break down squares and not squares. We label our first breakdown 1A and 1B. Our second breakdown 2A, 2B. We have the characteristic, square without dot versus square with dot. We have only one shape that belongs in that box without a dot, A, and only one that belongs in the box with a dot, B. Now, B is not the only shape with a dot. However, okay, E also has a dot. B and E both have dots, but E is not a square. So we don't care. We don't care that E has a dot because it's not in the box above. When you are breaking down your boxes, you only care about the critters listed in the box above. It doesn't matter if another one has legs or a heart or whatever, okay? If it is not in the box above, you don't care about it. You don't need to break that down. You break it down when you get to it somewhere else because it's already been separated out. C, D, and E have already been separated out because they are not squares. Does that make sense? I hope so. Okay, so once you have one letter, one species in a box, you're done. You can't break it down anymore. There's no more splitting to do. Okay, so if we look at 1B, are not squares. They are broken down into circle and not circle. C is the only circle. D and E are both triangles, so they're not circles. You can see it's in parentheses. It doesn't really matter. They're not, they could be a parallelogram. It wouldn't matter as long as they are not circles, okay? And so they are listed in the box. Make sure you list them. And then again, we use the feature dot and no dot, and that is fine to do as long as it is only once on an original side from the superset. So the superset's up here, and on the left original side, I used dot, no dot. I used it once. On the right original side, I also used it one time. That is fine. Don't use it twice on one side. It sends you in a loop, okay? But you can use them on either side. So if you use heart, no heart on the left of your superset and you use heart, no heart on the right of your superset, that's fine. Just don't use it twice on the same side, okay? Now, Everything is in a box neatly. Everything has the characteristic. Everything has the critters listed, and every single partition is broken down with a number and a letter. 1A, 1B, 2A, 2B, 3A, 3B. No C's, no D's. This is a dichotomous key, not tri, not quad, okay? 2. So you're only going to use A and B with your numbers. Now, the next part is actually really easy because you just follow your tree to make your key. So going down, we're going to use the shapes again. To make your key, okay, you have 1A, 1B. Start out. And you can, however many numbers you use, the least I've ever seen accurately is 7. The most I've ever seen accurately is 10, okay? Number them, 1A, 1B, 2A, 2B, all the way to wherever your last box, you know, whatever number your last box is. And then whatever characteristic you have in the box, you put on the correct line. So 1A is square, square. 1B, not square, not square, okay? I've had students put wonky stuff here, things that are not in their boxes, and I'm like, well, I gotta take off points because you're just following your own tree. Something happened, okay? So just whatever's here goes there. And then you tell your reader, okay, well, where do I go from there? Well, if you are a square, you're gonna go down to tier 2, division 2. You don't know which side of 2 you belong to until you get there, okay? You don't know that you're A or B. You gotta go to 2, you gotta read the characteristics, and then decide if you are 2A, 2B. Okay. So don't put ABs over here other than the name of the critter. I know, a little confusing, but other than the name of the critter. So critter A is identified at level 2A, okay? So we are square without a dot, we are A, okay? A is the species name. When you can't go any further, you just put the species name in the box, or I'm sorry, in the line. And so that's what you're doing, but you are doing it with these guys, okay? Now, I highly recommend that you use the presence or the absence of a feature as well as a characteristic of that feature. For example, look at the bugs. Some of them have wings. But what do you notice about the wings? Couple things. Well, some have single wings versus double wings. You can use that. Some have white wings, some have black wings. So you can use critter has wings, critter doesn't have wings. If it has wings, you're gonna put A, C, G, H, and I in one box. And if it doesn't have wings, you are going to put B, E, F, and I in another box. I still have a landline. Oh, jeez, sorry guys. There we go. Okay, then with the critters that have wings, okay, you can say double wings, single wings. You will put A in the double wing box and it will be identified. And then C, G, H, and J will be in the single wings. Then for those, you can break those down into white wings, black wings. Okay, kind of get the idea of how that works. So use the characteristic, use a feature of it, you know, on and on until you have them identified. And then this space, and you're gonna enter this into your activity. You can take a picture of if you did it by hand, or if you're gonna do it in like Word and, you know, draw, make boxes, type in a text box and do lines. You can do it that way if you want to. It's gonna take a little bit more time unless you're like super computer savvy. But if you want to do it by hand, make sure you follow all the rules. You don't forget any of the boxes and the numbering and the critters in there, and just make it neat. This is the one thing I gotta stress is that if I can't read it, I can't give you points. If I don't know what it says and I can't match it up to your key, I can't. I do the best with what you give me. So give me something that is organized and neat. Okay. I don't have the best handwriting, but I could still make this legible. So I have to be able to read it to give you grades. So just keep that in mind if you're going to hand draw it. Okay. And then again, this is the space to write your key. It goes up to 10. You will not do more than 10. If you get more than 10, something is wrong. Go back and look and fix it. Most students only get to 9. Okay, so that's the common. So if you don't use all of it, don't worry. And that's it. That's everything I got for you guys. So have fun doing this. It's a fun puzzle. And of course, always email me if you have questions. Until next time.